Hey all and welcome, and we are live. Hope you're all doing well. Sorry that it's such a late show tonight, but our power's off. We had scheduled load shedding, so yeah.
We are live. Hope you're all doing well.
Ooh,
Sorry that it's such a late
sorry about that.
show.
Let me get the Discord server going. Testing 1 2, and I hope it's working. Okay, like I said, sorry that it's so late, but yeah, we'd scheduled load shedding, so I could not have power to even stream. So everybody, hope you're doing well. Hope everybody's all warm and cozy. Say hi if you are here. I see I did leave a poll for whoever is interested. Does your perspective on life make a difference on reality? 60% says yes, 20% says no, and then another 20% says only for me yes. Hey Rob Ken, good to see you. Glad you could make it. Hi everybody else that's here. Hey Someday Dead, good to see you. Glad you could make it. Just for information, I took Ruhov off of moderation because it seemed he just went crazy and started banning a few flat earthers. Someday Dead, you were one of them that he banned. He banned Jeff as well. So sorry, Ruhov, you are no longer a moderator because you just went and banned them all for no reason. Hey Gary, good to see you. Glad you could make it. Thanks for joining. Yeah, it's a late show tonight, but it's going to be nice and chill. Let's hope someone would come in and present something on Discord. Yeah, Roof can't be trusted, Rob. I did give him the benefit of the doubt, but yes. Hey Sven P, good to see you. Thanks for coming. Hey Daz Studio, glad you could make it. It's good that everybody's here. I hope my sound's doing okay. Yeah. Like I said, so yeah, Ruhaf, after he got triggered and left last time, hasn't even tried to talk to me again, so yeah, that's what happens when they don't have anything. Andrew Johnson, good to see you. Glad you could make it. Hey Gracious Colf, good to see you. Thanks for coming. Andrew, I treat everybody the same with respect. If someone wants to disrespect me, I will take the hand and do what's necessary. Yeah, Gracious Golf, good to see you. You said you were in class or something. So, is anybody wanting to come into Discord? You're more than welcome. It is Discord Wednesday, so you can come in and you can present whatever you feel is your perspective on life. You can give any observation you want. You can really bring what you want, because the topic of tonight is actually just your perspective on how you perceive reality. Does it affect actual reality or just yours? That's practically what I was trying to see if we can talk about. For a bit of housekeeping, next week I'm not going to be able to do the Saturday stream, and the Sunday stream I'm going to do it in the evening because I'm having some family coming over. It's my daughter's birthday party next week, so everybody's coming to visit, and yeah, that's going to be quite exciting. Gracious Golf, we can present your video if you really want to, but like I said, the calculus at the end of it has got nothing to do with the actual conversation. But yes, we can present it. Let me actually see if I can bring it up for you. Gracious Golf. Yeah, let's see if I can present. Is it showing your page? Yes, okay. This is Gracious Golf's page, everybody. You guys, he is a Globe Believer, but you can subscribe to him. Anyway, he brought up a video lately, and let's see what he has to say. I hope the sound's going to work. As you can see, he's already showing some calculus.
It should just be a quick demonstration.
It's very soft though. Let's see if I can make it a bit harder, louder for you guys. Just for this video. Really hope it works.
Flapzoid. Flapzoid's been saying a lot about the usual needle.
I think make it a bit louder. Okay.
Horizontal baseline. To measure an elevation angle. And so I just want to show him where that all falls apart. Because here's how an observation goes. Imagine someone's holding a sextant here. They look up. This orange line is to the sun, and this purple dashed line is going down to the horizon ever so slightly. We follow it. It does end up hitting the ground at about 5 kilometers, and that leads me to the next point. This is all to scale. This is 0.0015 kilometers, so Nathan, can you tell me how many meters that is?
I don't know. How do you convert meters into kilometers?
That's 1.5 meters off the ground.
Gracious Colf, would that be a physical horizon? In other words, a geometric horizon, or your refracted horizon? Let's just quickly, before we go on, just check what you say about that. Calculus is coming afterwards, Gracious Colf, at the end of the video. Because you're trying to do a challenge for calculus at the end of the video has got absolutely nothing to do with the sextant, but yeah. So I just want to find out, is that to your geometric horizon, or is that for, we're going to show the rest, Gracious. I just want to find out, is that to your geometric horizon, or is that to a refracted horizon? You know, it would be easy if you actually came in and talk. We're getting there, Gracious. I'm asking you one simple question. Is it to your geometric horizon, or is it to your refracted horizon? The video shows me. Okay, so I'm going to take it as your geometric horizon then. Is that a yes? Okay, we'll take it as geometric horizon, everybody. Let's go to the video. Is it showing? Yes, okay.
Before I move on, we can agree. We can measure this angle.
Actually, you cannot really measure that angle because that is a curved line. You cannot have a curved line to have measure angle because this angle would be different here than this angle here and this angle further down. Then, in other words, it's not really an angle. The only angle you would have is the vertex angle. So literally just that point would be an angle. You won't have any other angles. You need two straight rays meeting at a vertex. So not really. The angle is simply there because your ground would have to be flat to have that. Now because you're making a curved line, it's not an angle. Just had to point that out.
Flapzoid, I have a little secret about this diagram here. It's not on a horizontal baseline.
There we go. So therefore not an angle. Not on a horizontal baseline. Do you see what I'm talking about? Do you see what I said with the comments earlier where you've duplicated your angle reading on a horizontal and duplicated to the center of your radius so you can have your angle measurement? Do you understand what I'm saying? This angle measurement is to the sky on a flat horizontal baseline, hence elevation angle, straight. Just because you make it curve downwards to your geometric horizon does not make it an angle. The straight 180 degrees is an angle. You require two straight rays. So you've actually done yourself in just by doing this alone. Because you see that perpendicular, that parallel to that, that is your angular measurement. That's a parallel. Or is that also curving? Because I don't know, that looks kind of horizontal to me. So anyway, like I said, you duplicate your angle based on the horizontal baseline to the center of your radius. To say that what we measure this angle, this co-altitude angle in the sky, is now this angle on the ground. It's duplication because you have a belief of a sphere.
It is on a circle with a radius of 6,371 kilometers. And these orange lines go to the sun. We can see this is the GP.
Problem is, you moving it to the center of Earth is saying that that is the same GP as where you took the measurement, because with a sextant reading you have it on the same horizontal plane.
And then this was the one we were looking at earlier. There's that purple line. I'll show you it hitting the horizon too. About 5 kilometers. Just 2 meters below true horizontal.
You see that horizontal, that elevation angle, that is 180. That's where your angle is measured from, not to that. That's a curved line. That's why when you do a measurement, you do height of eye correction, your dip correction, because your eyes are not embedded in the ground, which is horizontal. That's why you have what they call a sensible horizon. It's what's touching the apparent horizon, which is horizontal. Are you getting my drift?
They intersect. And then, big step back, we can see the sun. It is as far away as it is to scale, and big as it is to scale. Here.
I want to know, how did you get that scale? Was that done using begging the question based on a radius that was debunked by the black swan in the first instance? So how did you get this actual size? Did you measure the sun actually, or did you calculate it based off of a flat baseline?
Are those same 2 orange lines. You want to measure this angle, make sure those are perpendicular.
It would be perpendicular because you've duplicated it. It's a duplicate angle measurement. It's common sense.
On the globe, what is the point of finding this angle? Well, this angle is ever so slightly bigger than this angle.
That's why you use co-altitude angles to get your distance.
So if only there's some way to compensate for that slight size disparity.
You first have your angle measurement, which you get, aka your co-altitude angle, to get your distance. This is done afterwards, once you've begged the question of a globe. You've taken a flat measurement and duplicated it to the center of your globe so you can have your beloved curve. This so-called curve is the measurement you measured in the sky. You have reified an optical curve as your physical ground. That's the argument which you are validating for me when I say you've just duplicated your angle.
Only there's some sort of correction we could do for the subtle dip that this purple line has. And well, obviously, that's what dip correction is for.
Yes, because your eyes are not embedded in the ground. It's great that you use the elevation angle for that, which is a horizontal plane. The dip correction comes before you actually do anything, because you have to have 0. When you pick up a sextant, you actually have to move the sun down to touch the horizon. Why is that? So you have your plane meeting together.
This angle is ever so slightly bigger than this one, so you subtract off that extra bit for how high you are, because that determines how far you had to look down, which is how much you widened this angle. And so once you've corrected this angle, it's equivalent to this angle, which is alpha. And this angle is very useful because it is complementary to beta.
Do you guys also notice how this is a horizontal? And yeah, he's trying to get the angle measurement from a curved baseline and then saying they do not match because, yeah, I wonder why.
And once you have that angle beta, with the radius of the Earth, you can find this arc length.
What radius of the Earth? How did you get the radius of the Earth? Did you use a flat baseline to get the radius?
With arc length to the GP. Then look, I can really quickly pop up another observation 45 degrees the other direction. I'll do that right now. So here you have the second observation 45 degrees. There'd be someone standing
45 degrees looking to the same location. And what is this showing now? Does he have a new horizontal? A new elevation angle? Weird.
on the surface here. And they are looking up to the sun. And again, this line goes to the sun. I can show you again. This line is 1.5 meters off the ground. It intersects the horizon about 5 kilometers up.
Do you realize we do not see an orthographic view? Just had to point it out. We see three-dimensional. So when we look out, we have a field of view bubble. We see things in perspective. So those measurements you take in three-dimensional reality is now trying to be converted to physical curve. That's the bottom line. And what you're doing here is exactly what I said. You're validating my point. Taking a flat angle measurement and reifying your globe after the flat angle measurement. Also I want to ask you, since you call this your geometric globe, those sun rays, are they straight lines or are they curved lines? I wonder if the sun rays are parallel or divergent, because if we go and look at what light rays come from the sun, it's definitely not parallel. And it can't be parallel if you guys have refraction the whole time.
Looks good to me.
Anyway, I think I've made my point very clear. Put this a bit softer again, because if I don't, it's going to blast everyone's ears away. The angle measurement is not from... Yes, the angle is from a flat measurement, Calf. Exactly, Sven. Like they have to cut the globe in half to obtain the equatorial plane. Hey Alan, good to see you. Glad you could make it. Thank you for coming. Gracious Calf, so the lines are straight. Great, so no refraction then. The purple dashed line was not your angle measurement. Your angled measurement was a horizontal 180 degree line. If you hadn't realized that, that's what the system showed. Let's go back there. I'm going to show it now when we zoom it in. Just find it quickly before... there we go. Yeah, quickly put it on for you guys. Is it showing? Yes, you see that line? That is your angle measurement. It's taking the angle measurement from that 180 degree line, not that little curved line that's curving downwards. That's not the angle it's taking it. It's taking it from 1.5 meters off the ground with that elevation angle. You understand that baseline? It's the baseline. See if we can zoom it back again. Maybe you can... Oh, there we go, showing here. You see that? That is the elevation angle, because that is where it's taking that angle. There's your angle measurement. Just because you're 1.5 meters off the ground, you think this angle measurement and this is the same. No. This is your angle measurement because that is your baseline, not that. That is not an angle measurement because it's a curved adjacent. You do not have a curved adjacent angle. You need straight rays to have an angle measurement. Therefore, when you move your eyes into the ground, height of eye correction, that is the angle measurement you have. So this angle, which is actually here now, is your co-altitude angle and the angle you measured. The co-altitude angle gives your distance to the GP. It falls on the same horizontal plane. So yeah, I think next time you maybe have to actually know what's going on with the conversation before you try and say it's a challenge. I don't chant any Nathan, I tell you straight as it is. Wait, what? How does the sun move over Flataria with being affected by perspective? The sun is the thing moving, you watching it converge into the convergence zone. That's how it works. The purple line is not horizontal, is it, gracious Kolf? It's showing downwards. So, yeah. The horizontal baseline. Otherwise, you don't have a perpendicular of 90 to have an angle measurement. So, it does not work. You need a horizontal perpendicular. Your zenith has to have a horizontal of 180 degree horizontal baseline to have an angle measurement. If you have made that horizontal baseline slanted now, you don't have a 90 degree angle to measure it from. Do you understand the problem? So that was very simple. So yeah, we can add that to another globe validates what we've been saying. What is an elevation angle, gracious Kolf? Maybe you haven't paid attention. I can always bring up. It's slightly wider. That's why we do dip correction. No, we do dip correction because it's called height of eye correction, because your eyes are not embedded in the horizontal plane. It's not embedded in the ground. When you use a sextant, you move the sun to touch the horizontal line, the horizon. This is your sensible horizon. It is horizontal. It's a 180 degree line. When you pick up a sextant and you do that height of eye correction, you are simply making it based on that horizontal line, and because it's touching the horizon, you have thrown your globe away because it means the horizon is on the same plane, 180 degree plane. I see a lot of globe believers in here. Exactly, Sven. Dip correction is the gap between your eye level and ground level. That's exactly what height of eye correction is. It's because you have a height above the ground. We live in three-dimensional space. The purple line is not an angle measurement. To have an angle measurement of a 90 degree, you require a perpendicular. It's not perpendicular if it's slanted, gracious, that's what I'm telling you. That angle measurement that was taken was off of that other line. This line was the angle measurement, not that line. No matter how bad you wanted to say that is your angle measurement, that is the angle measurement. You know why? Because it has a perpendicular. You are just simply taking your height of eye when you pick up a sextant and you moving your height of eye there. You moved it down. Therefore, this angle measurement is what you are measuring now. Get it? And your co-altitude angle is based off of this measurement of a 180 degree line. Baseline flat. I don't know why I have to still explain this to you guys. Yep, it's in the center of Earth apparently, Sunday Dead, which they do after they take the flat measurements. That baseline wasn't flat. Yes, the baseline was flat, Gracious Golf. It's 180 degree. Do you know what a 180 degree line is? It's flat, horizontal. Hey, Davey Z, good to see you. Glad you could make it. No, it wasn't. Your circle is touching that horizontal baseline. That program, if you haven't realized, has a Cartesian coordinate system. It has an X and a Y. It's a perpendicular. You place that circle touching that perpendicular. Then you say it's curved. No, it's a horizontal plane. It's called an elevation angle for a reason. A circle is a two-dimensional shape, Wiggles, if you haven't realized that. One thing you guys cannot understand, what's the difference between two-dimensional and three-dimensional, that's for sure. Okay, so the poll says, does your perspective on life make a difference on reality? 50% say yes, no 28%, and only for me 22%. It's quite interesting how 50% of people say what you believe makes a difference on how reality is. I'm taking that as mostly being the globe defenders, because they do not understand. It doesn't matter what your opinion is and your perspective on reality, it doesn't change what reality is. So yeah. No, Gracious Golf. That's great what you say. You don't understand anything clearly. I just explained it to you as simple as I could to you. That seems you are the one not understanding. Okay. Such patient flirts. Yeah, I'm trying very hard someday, dude. It's like you kind of grow hair on your teeth, these guys. So yeah. If you want, we can always go look what an angle is. Let's go. Yeah, I think let's try and see what is an angle. This is for you, Gracious Golf, because you seem to think angles. Adverts quickly. Let me just quickly first go past the advert before we play the video.
And how they're measured. The concept of angles is very simple. To know what an angle is, we just need to know what a ray means.
Yeah, what's a ray? As far as I know, a ray is a straight line, is it not?
Look at this point.
Would that be a vertex?
If I draw a line which starts off from a point and goes
Starts off from a point and goes in a straight line.
indefinitely in one direction,
Did you hear that? Indefinitely in one direction. So that means it's a straight line. It doesn't curve.
it is called a ray. This is one ray, and if we have another ray like this, then what we have between them is called an angle.
Ha! Two straight rays meeting at a common vertex. An angle.
Note that the two rays originate from a single point. So an angle can be defined as some measure between two rays. What are these two rays called? These two rays are called the arms of the angle.
Can you have a bent arm to have an angle? No.
This arm where the angle starts is called the initial arm, and this arm where the angle ends is called the terminal arm.
So the initial arm with using your sextant requires a 90 degree, which means that initial arm cannot be lower than the 180 degree, because your base is 180 degree. You are doing a triangle. You are triangulating. You understand? So when you make that initial arm bend downwards, it's no longer viable as an angle measurement, because you require it to be perpendicular to your vertical.
Both the arms of the angle meet at one point. This
Meet at one point. So when you guys say you have a curved line, they cannot meet at one point. At any point can they meet at one point because they're curving away from each other. Different angle measurements at every single point then.
This point is called the vertex. Two rays meet at one point to form an angle, and we also refer to it as the origin, as both the rays originate from this point.
Very simple. Both arrays original from that point. Well, I think that makes it very clear. Again, gracious Golf, the line is not curved, the purple line. The purple line is sloped downwards. Because it's sloped downwards, it's no longer the elevation angle because it's already gone below the angle. Do you understand? No, level doesn't curve, Flat Sabbath. 100%. Correct, my purple line did not curve. So, the purple line did not curve, so you didn't have an angle because you placed it lower than the perpendicular. Wiggles. The definition for angle between curved lines is not what is used on a sextant. A sextant uses 90-degree angles. Therefore, it uses a perpendicular to vertical. It doesn't have a curved adjacent. You can have two circles meeting to touch at a vertex with a straight line, with a tangent, obviously, but you do not view things like that in reality. When you take an angular measurement, you are literally standing on a horizontal plane, having your vertical perpendicular. That means you are standing at a 90-degree angle, measuring something. That's why you have a co-altitude angle and your altitude measurement. It makes a 90-degree angle. These 90s come off of a 180-degree plane. This is the most base. Yes, a sextant is 60 degrees, but the 60-degree sextant comes off of the 90. Hence why you're measuring co-altitude angles. You standing 90 degrees, you're not standing 60 degrees. Let me try and look for something for you guys quickly. I think this guy does quite well.
Creating your first video.
Just gonna quickly get the advert for Bay. Skip okay. Let's see. Get it on.
The end of the evolution of a lot of instruments that were used to cite the altitude of stars.
Yeah, okay, we really don't need to see that.
You're seeing a physical horizon, and you have the altitude of a celestial object, which is the angle from the horizontal to how.
The angle from the horizontal. Let's rewind that quickly what he says.
From the horizontal, angle from the horizontal, celestial object, which is the angle from the horizontal.
Celestial object, which is the angle from the horizontal. Do you see your issue there?
To however high it is, and then the other angle is called the azimuth, which is
The azimuth is that way. Across the 180-degree plane. Across the plane, that's the azimuth.
basically dividing up the horizon into 360 degrees.
Yes, because you see 360 degrees around you. Your field of view, bubble. Very interesting, isn't it?
Use the information about its altitude and its azimuth to estimate location.
Okay, let's
But
see.
number two is this mirror here is on a movable.
That's why it's 60 degree, gracious Golf. You see that movable arm, because that is a 60-degree angle. The guy is standing at a 90-degree angle. This is what I was trying to explain with the video before when people misrepresent me and say I'm saying this is a 90-degree angle. But yeah.
In this case, will reflect off of this mirror, and I can put a filter.
Yeah, he's just
And I'll see
explaining.
the image of the sun brought down to the horizon, and then by manipulating this down to the horizon, and this partially silvered mirror, and I'll see the image of the sun brought down to the horizon. Sun brought down to the horizon. Image of the sun brought down to the horizon.
Why do they do that? They bring the image of the sun brought down to the horizon, the horizontal plane. Do you guys get what is happening here? Huh.
And then by manipulating this lever arm and this little veneer screw,
Yeah.
what I can do is get the altitude of the sun to a precision of about an arc a minute, which is 1/60th of a degree, which
Whoopsie. And how do we get our nautical miles? Is that an arc measurement in the sky? Degree measurements?
represents 1 nautical mile of uncertainty. So that's the kind of precision with good practice.
Yeah, so it makes it very simple. He brings it down to earth, down to the horizon. This is actually very, very simple. Lever horizon, not oblate. Exactly, flat Sabbath. Anyway, hi everybody for joining. Whoever's ever just new here, thank you for coming in. Mandela effect, good to see you. Yes, Mandela effect, exactly. The reflection of the sun on the ocean proves the earth is flat. 100% agree. You want us to keep watching, Grayscoff? Okay, let's go back to it and we can carry on watching it. Still makes our point.
You can get with a sun sighting.
Just want to make sure. Yes, it's showing.
So what I'm doing now is I'm sighting the sun, which is up in the sky. I put down a little shade so I don't burn my eyes out.
And you know this angle measurement, he's making it what? Parallel to what? He's horizontal. Do you understand? If you don't have a horizontal baseline, you cannot have a horizontal reading. He's bringing the sun down to the horizontal so he can have a what? A parallel.
And then I try to find its location by roughly scanning back and forth. I adjust it so that
That's actually quite a beautiful sunset, don't you guys think?
the lower limb of the sun, that is to say the lower part of the image of the sun, is just touching the horizon. Is just touching the horizon. Is just touching the horizon. And I look at my watch. 8.
I have to ask you guys, is it physically touching the horizon or is it just optically touching the horizon based on his measurement? Yeah.
37:45 Eastern Daylight Time, which I can then
Yes, you see, you take it with time because it moves in the sky. Remember, guys, I said you take it with time? Sean Hawkins?
turn into Greenwich Mean Time. This is a coarse reading in degrees, so you can see that we ended up with about 30.
You see, that's your arc measurement, guys. Degrees, you get it? Arc measurement in degrees, that's how you get your arc minutes, so you can get your nautical miles.
36 some odd degrees, and then this little drum here tells you how many arc minutes. An arc minute is 1/60th of a degree.
Woo-hoo-hoo. Can we make it any more plainer to you guys? This instrument can only work with a horizontal baseline. This instrument shows you how you get your nautical mile distance. It's not a globe, it's based on flat.
So I read off here that I got 23 degrees, and then this little set of lines here called vernier allows you to then get tenths of an arc minute.
So you got the arc minutes from what? A horizontal baseline.
What I now can do is do a few corrections. One is for the refraction of the atmosphere, one is for my height above sea level.
Yes, sea level is what? 0 degrees, is it not? It's mean sea level means it's at the 180 degree baseline. Now he's made his measurement on the flat baseline. Now he's going to measure in refraction, which is usually only done around about 20 degrees below because that's where it's the worst. And his height of eye because his eyes are not embedded into the ground, remember?
And something called an index correction for my instrument.
Obviously.
And then once I get
Obviously you have to do an index correction. Instruments are finicky.
the true altitude of the sun by making these corrections, I can then go to a set of tables that
So you guys understand when he says true altitude. So if you're taking a true altitude and you're making it 90 degrees, it's you guys saying it's got an actual height. And if you measure it to an actual height and it comes, let's say 3,500 nautical miles, you guys are saying that's the actual height of the sun. Kind of blow your own argument out of the water, don't you? Because you guys are the only ones saying it's physical. We're not saying it's physical. It's an apparent altitude angle measurement, not a physical altitude angle measurement. Apparent.
I can use to just basically add and subtract a set of numbers and give me a prediction for the altitude of the sun for this moment, if you like, and then for assumed latitude and longitude, and then I can
Yep. Simple as that.
basically do a little correction and figure out where my line of position is.
LOP, line of position. Okay, there's a Golf, so are you happy we could watch the whole thing now? Stop spamming, yes, he's kind of spamming the live chat. Pirate Man, let's see, good to see you. How do you manage to get absolutely everything wrong? What have I got wrong so far, Pirate Man? Have I not been saying everything that these guys have been saying? Weird. We can get more on the Sextant if you guys really want. I think we should, because you guys really don't understand. Let's see if I can find something more for you guys. Oh yeah, let's see. Anyone in chat do it? No one's actually joined me in chat yet, so yeah. While I'm still waiting for people, I'm going to carry on berating you guys and showing you how a sextant works using flat, because that's how it works, people. Sorry to tell you this, but it's not a globe. I'm looking for a specific video. I really hope, I just don't know the name of it. Still navigation. I hope it's gonna pop up soon. I'm looking for it. There we go. I think it's this one. Yes, okay.
Chasing that.
Just gonna let the advert go away first. We do not need to show adverts, do we? Oh, this is quite good, yes. Okay. If you guys are ready, let's go. And it's showing, okay. Pay attention, Globies.
Radius and is concentric with the Earth. They gave this sphere a name, celestial sphere.
You see this celestial sphere? This is all done in what? We measure this celestial sphere in three-dimensional reality, do we not? So in other words, it's an optical sphere. It's not a physical sphere, people. It's optically a celestial sphere. That's why it's called celestial sphere. It's a make-believe sphere. It's not literally a sphere. It's an optical. I cannot stress this enough for you. Optical, and is based on your field of view.
And we still call it that today.
Mm.
From Earth, it appears to move from east to west.
Ooh, so it rotates once every 24 hours, the whole celestial sphere. So it's not us rotating, the stars are rotating. Interesting.
One complete rotation every 24 hours. Over the years, astronomers have selected 57 easily identifiable stars on the celestial sphere for navigational purposes.
Makes sense, don't you think? Because stars have got cycles and the way they positioned through the centuries. It's weird how the people used the same type of thing before it was said to be a globe. Yeah, and they could also navigate with stars and telling times and seasons with stars before it became a so-called globe.
The rest can be disregarded. In addition, navigators have traditionally used the planets Venus, Mars, Jupiter, and Saturn, the Earth's moon, and the Sun. To understand how these celestial bodies are used for navigation, you must first review some basic terminology.
Please pay attention now. Basic terminology.
Let's begin on the Earth, or the terrestrial sphere, as it is sometimes called. The Earth rotates around an imaginary line called the axis. The intersection of...
Notice how you have to beg the question straight away. And no, there's no such thing as Earth rotation because you cannot prove that it rotates. Speaking of which, I have a video coming out 1 o'clock Central African time tomorrow. Please do go and watch it. I have put it on for premiere. It's about Coriolis.
The axis and the surface of the sphere are designated the North and South Poles. A plane that cuts through the center of the Earth creates an arc on the Earth's surface known as a great circle.
A plane. So that would be your great circle. So in other words, they would make it a what? The equator, the great circle. That would be your radius. But what is this radius based on, I wonder? I will get there.
Can be any number of great circles. A plane that includes the Earth's axis creates a great circle known as a meridian.
Very interesting. The meridian.
There are an infinite number of meridians, and they all pass through the North and South Poles. The meridian that passes through the Royal Observatory at Greenwich, England...
That's why we get our time, you know, Greenwich Meridian time. Like us in South Africa, we are 2 hours ahead. So when we take an observational time, we have to put the 2 hours ahead to keep that time so we know where we are with the longitude.
has been selected as the prime meridian. It is the meridian used as the origin for measurement of longitude.
Eesh.
Longitude is the angular distance measured at the poles from the prime meridian to another meridian, east or west, from 0 degrees.
So in other words, on a 180 degree plane, this is why you have your 360 degrees on a 180 degree plane.
To 180 degrees. The equator is the great circle perpendicular to the Earth's axis.
Perpendicular, you heard that? So in other words, if you have perpendicular, it has to make a 90 degree angle. You understand? 90 degree. It's a 180 degree plane. Remember what they said? This great circle is a horizontal plane. Okay?
It is represented by the letter Q. Latitude is the angular distance from the equator measured along a meridian north or south from 0 degrees to 90 degrees.
Let's listen to that again.
Is the angular distance from the equator measured along a meridian north or south from 0 degrees to 90 degrees.
One more time. I think the Globers need to hear this.
From the equator measured along a meridian north or south from 0 degrees to 90 degrees.
So it's north or south from 0 degrees to 90 degrees. Does that look straight across that horizontal plane to you guys? Is that two straight rays, gracious Colf? Is it measuring an arc? Is it measuring the arc there? Okay, it's gone.
The great circle distance of the arc along the Earth's surface is called arc distance.
Arc distance. So, in other words, the measurement we take. See that? Let's see what that does. That's the measurement we actually make. What? On the celestial sphere. Do we do this on the ground? No, we take this on the celestial sphere. You guys reinforce this and say, listen here, that optical measurement is actually physical. So we're going to take that arc distance we measured using what? A sextant of the sky, and we're going to say, let's move it to the center of our presupposed Earth and say, because we had a flat measurement, we now are going to say it's physical.
It can also be translated into linear distance.
Whoops, what? It can be translated into linear distance. What the hell did he say?
It can also be translated into linear distance.
Oh wait, I thought linear distance does not work using flat. What is that? Let's go back a bit. I think we've got to re-hear
On
this.
the Earth's surface is called arc distance. It can also be translated into linear distance.
So, linear distance. Sorry, McToon. Sorry, Ruhov. Sorry, everybody else. What did he just say? Linear distance after you guys told me it's not linear distance? You know why it's linear distance? Because of this. Because of that arc is a relationship based on this. So yes, it's a linear function.
1 minute of arc equals 1 nautical mile, or 1 degree equals 60 miles.
Let's reiterate this. Minute of arc on what? On the celestial sphere arc equals 1 degree equals 60 nautical miles. On what? Celestial sphere arc. It's actually very simple. I'm trying to look for this. Should be more. Oh yeah, that should be interesting.
It's just a way of saying that the planes at the same angle. So an angle observed at the surface of the Earth is really the same as that at the center.
Oopsie. What did we say about duplicating angles? So we're standing on the surface of Earth with a horizontal plane. That's 180 degree, called an elevation angle. Because you have a belief now, you need to duplicate it and move it where? To the center of Earth.
Suppose the angle is 0 degrees.
0 degrees. Gracious Golf, do you understand that? What was your angle that you're giving that slope? Would that be below 0 degrees? So in other words, it's not an angle taken by a sextant. Ouch. Yeah.
The celestial body will appear to be on the celestial horizon.
Celestial horizon. This would be 0 degrees. Remember when I showed you guys 5,400 nautical miles from Polaris to the equator is showing that?
This is just a way of saying that the thickness of the Earth can be disregarded in celestial computation.
Ah, that's gotta hurt.
The same as that at the center. Suppose the angle is 0 degrees. The celestial body will appear to be on the celestial horizon. This is just a way of saying that the thickness of the Earth can be disregarded in celestial computation.
The thickness of the Earth can be disregarded in computation for the celestial navigation. In other words, no globe. No globe, people. You heard it from them. No globe. You do not use globe to make a measurement. It is simply horizontal plane. Horizontal plane to perpendicular. Yes? Horizontal. You have 0 degree, 5,400 nautical mile away because it reaches a field of view limit. 100% understand? Yes.
The measured angle of a celestial body from the celestial horizon is called altitude.
Again, that altitude, what did he say? From the celestial horizon, which is an elevation angle. So 180 degree angle. Gracious Golf, I hope you understand. I hope you're paying attention here.
It is indicated by the letter H. Altitude, when computed, is called HC. It is called HS when it is sighted through a sextant.
When sighted through a sextant, it is now called HX. Why? Because that's the altitude measured through the sextant.
And it is called HO when the sextant reading is corrected for instrument and observation error.
That would be after your height of eye correction and data, which would give the corrected altitude. Which, that's why we're saying it's all an apparent altitude measurement, because you're making corrections. It's not a physical altitude, it's an apparent altitude. Thank you, perspective.
It is easy to confuse altitude with declination. But remember, altitude is measured from your celestial horizon.
I'm going to replay that just so you can hear.
Declination. But remember, altitude is measured from your celestial horizon.
From your celestial horizon. That would be this celestial horizon. And that would mean this is falling on the same plane, the same GP. The GP of the star is on the same plane as your GP. Same horizontal plane. Why? Because you have a field of view. This field of view dome is what you're measuring. That's why this star appears to be arcing. It's not literally arcing, it's perspective.
Declination is measured from the celestial equator. For example, the declination of Polaris is approximately 90 degrees. But its altitude varies depending on your location on Earth.
Its altitude varies depending on your location on Earth. Sean Hawkins, please pay attention here because this debunks your whole Polaris argument.
Polaris is approximately 90 degrees. But its altitude varies depending on your location on Earth.
Its altitude varies depending on your location on Earth. Let's hear that. I don't think you were hearing that right.
But its altitude varies depending on your location on Earth.
Wow! Does this not validate my whole graph I made? Weird. But let's carry on.
It stands to reason that the angle of altitude will always be less than 90 degrees unless the celestial body is directly overhead.
Very simple, is it not?
The farther you move away from the GP of a body, the smaller the angle of altitude.
Oh, another validation to my presentation.
The closer you come, the larger the angle.
Can you guys see what's happening here? Is that seeming to have a following an arc? Is it still based on the same horizontal plane? Is it having an apparent altitude change?
The difference between 90 degrees and the observed altitude of a celestial body is called co-altitude, or zenith distance. This is an important angle to remember when you begin to use celestial navigation to plot a line of position.
Ouch. And that's how we get our what? Our distance. Co-altitude.
Because zenith distance can also be expressed in nautical miles on the surface of the Earth. Let's say you have obtained a sextant observation of 70 degrees on a star.
Please pay attention.
You can see that a 70-degree measurement can be made from any number of points. You immediately know that you are someplace on this circle.
Circle of equal altitude. It's based on the same horizontal plane. Is that a 90-degree angle from the GP to your GP? If you have GP on the circle, it's all based on the same horizontal plane. Whoopsie. Kind of destroys the argument here by the globe. But let's first see what you guys have to say in comments. I'm really excited to see what... Okay. Let's see what you guys are saying. Davey Z, because math can show an abundance of things that cannot be replicated in real earth and time. This is very basic, Flat Sabbath. Very basic. And the thing is, it just validates everything I've said. If people haven't... I don't think Flats would on a single... Brenda understand every single word. Everything it's been saying is validating what I've been presenting. I think for the people that haven't seen it, maybe I should show my presentation again in short. And then take note of what he said. Okay? Because this is actually very, very simple. So I'm going to present it again as quick as I can, as nice and can, just see if you guys will understand. Let's see if it's showing. Yes, it's showing. Okay, remember what they said now. This is Mike again, standing underneath Polaris. This is his horizontal, remember? celestial horizon. So in other words, he has an elevation angle, which is 90 degrees. He is standing at the GP under Polaris. 90 degrees is what he's measured. So we have to minus the 90 degrees because he measured 90, and it will give us 0. So 0 times 60, which is our degree of arc. We measured no degree arc, so it's 0 nautical miles. So in other words, he's 0 nautical miles distance from Polaris. Let's say Mike stays there and Bob walks 600 nautical miles away. That would be 10 degrees. How did we get 600 nautical miles? Simple. He has his 90 degree. He has to measure what he measured. He has to take away what he measured. He measured an 80 degree angle. That is apparent altitude angle. So he minuses that. What is 90 minus 80? Would that be 10? Yes. Okay. So we take the 10. That would be his co-altitude angle. Remember we spoke about the co-altitude angle. And he times it by 60. Why? Because 1 degree equals 60 nautical miles. He measures an arc degree. So that gives it 600 nautical miles. What are we seeing the relationship happening here? Quite interesting, don't you think? So let's see. And he just has another friend walking away, and it's going on and on and on. Wow, what are we seeing happening here, guys? Simple. Does it have an apparent altitude change? Yes. What was this guy showing before? I think he showed something like where was it? Let me quickly find it, because this was quite interesting. Oh, okay. This is just giving the linear relationship. So let's maybe listen to that again, because maybe somebody missed it.
The great circle distance of the arc along the Earth's surface is called arc distance. It can also be translated into linear distance.
So, again, this arc is what we're going to translate into linear distance. This is the formula to have that linear distance. Your co-altitude angle is how you get your linear distance. This looks uneven because it's keeping to the arc measured. In other words, it's optical. Simple. That distance is the same 600 nautical miles difference as that. They're all 600 nautical miles apart. But it looks optically, why? Because it's keeping to the relationship of that arc. The linear relationship. As that is getting compressed in the distance, so is that angle getting compressed in the distance. Because a 60 degree angle measurement is an apparent altitude angle measurement. It's not the same as a 20 degree. It's simple. Let's see where they say this again for you guys. It's amazing that we have to teach grown adults this over and over and over again. So I'm just trying to look where they're actually showing you it's moving. I think it was here. Okay.
Body will appear to be on the celestial horizon. This is just a way of saying that the thickness of the Earth can be disregarded in celestial computation.
Yeah, the thickness of Earth can be disregarded in celestial computation. Why? Because there is no globe. You are using a flat horizontal baseline.
The measured angle of a celestial body...
Sorry, did it not seem to be arcing up, people?
...from the celestial horizon is called altitude. It is indicated by the letter H. Altitude, when computed, is called HC. It is called HS when it is sighted through a sextant. And it is called HO
when it is corrected.
when the sextant reading is corrected for instrument and observation error. It is easy to confuse altitude with declination. But remember, altitude is measured from your celestial horizon.
Remember, altitude is measured from your celestial horizon. Ah, there we go. There we go. Okay. Pay attention now on this, please, and listen to the words he says again, because you saw my graph now. Pay attention.
On your location on Earth. It stands to reason that the angle of altitude will always be less than 90 degrees, unless the celestial body is directly overhead. The farther you move away from the GP of a body, the smaller the angle of altitude.
So, is the angle of altitude the same here as it was there? Does it appear lower to the horizontal plane than it was there?
The closer you come, the larger the angle.
Ouch. That really, really is bad for you guys. Tell me again how I don't understand, please. Tell me how this does not represent that. Anyway, let's go on. Now we're going to show with the field of view, your celestial sphere. He's moved away. His celestial sphere moves with him. See where it's touching? The 80 degree. He's measuring an 80 degree. Now he's measuring a 70 degree and he's moved away. Now he's measuring a 60 degree. Is it not having a linear relationship to the distance? Oh wow. Something is really not working here for you guys. This would be 0 degrees now. What did they say when it reaches 0? And this math works out in reality. Why? Because this is what it's based off of, people. Your globe radius is this. Your equator is this times 2. Why? Because this is a 90 degree angle. So obviously it's again that side. It's just a quadrant measured. A quadrant optically measured. So it would be 10,800 nautical miles. See what I'm saying? 10,800 nautical miles. Any questions? Okay, so I think I'm making it kind of very easy to understand for you guys. So Gracious Colf, have you caught up now what the actual argument is and how your video validated everything I just showed? If I fired a crossbow in a vacuum, would it recoil? What has that now got to do with what I was showing? So in other words, it's showing you guys are ignoring what I'm presenting because the cognitive pain is too much. Very sad. But hey, 28 people in here, good to see you. Yeah, we started the stream very late tonight. It's already been an hour and a half, can't believe it. So I'm not going to go later than 12 o'clock, unfortunately. So just another half an hour, guys. I got work in a few hours. But yeah, I think I've made it quite, how can I put it, showing you that what I'm explaining is true. Hi Adam. Yeah. Adam, great to see you. I'm glad you could make it. You can come in and Discord and chat if you want to. I've still got about a half an hour to chat. I hope Decimals he sees it. I haven't seen him around for a while. Do you have his contact details actually? But yeah, it's a simple point, which you guys, they just ignore. Yeah. Yeah, I like Gracious Golf, guys. He's actually a very nice guy. So I wouldn't badmouth him or anything. He is he's still young, he has a lot to learn. And while he is actually a very bright guy, he's very mathematically inclined, so I do give that to him. That sucks, Mandela. How many strikes did you get? Pirate Man, why do you show a video with a globe? Because the globe is based on flats. I have to show you using a globe how it's not based on a globe. Pirate, that's how it works. Yeah, Adam, do you have Discord? If you do, you can always come in and talk again. It would be great to hear your take on how I'm presenting it, because I am trying really hard to make it simple for these guys to understand. If you guys haven't already, please just do hit that like button and share. It does help to get the show further out to everybody. And great news, I should be monetized by the end of the week. Yeah, I said the thing has been, they have been reviewing it for the last 3 days or something, so that's quite great. It's going to be quite cool because then I wanted to next week start the debate evening, but it's not going to work because, like I said, I'm having family over and stuff for my daughter's birthday, so I'll do it the week after that. I'll have the launch of the new. Hey T Brown, yeah, sorry about that. I had to unblock you. Ruhuf actually blocked you, T Brown. Can you believe it? He blocked a few of you guys, so I unmodded Ruhuf. The bloody cow went and even Someday Dead, and I think it was Jeff Gashead and everything. He blocked you guys. He banned you. So I removed Ruhuf from being a mod on here. I gave him the benefit of the doubt, and he was just being dishonest. So yeah, sorry about that, T Brown. Sorry about Jeff and Someday Dead, and there were a few others. I did unblock you guys, and Ruhuf is now not a mod anymore. Adam Eakin, you are being modest. At the 2019 Amsterdam conference, he said that graph was the question if he had to answer. How's it going, John Watson? Good to see you. Glad you could make it. Anytime, T Brown, you rock, dude. Really do appreciate you guys' support. I really do have great subscribers, and even you Globers, thank you for coming. Without your support, this channel would not be growing as good as it's growing now. So yeah, my channel is actually doing better than it's ever done since I've started, so I'm not going to moan. So yeah, Conspiracy Cats, if you want to know, because he has been messaging me lately, telling me how my channel is stagnating and dying. I don't see it, I see the exact opposite, but yeah. Okay, no, it's fine, Adam, we can always have it another time. Yeah, guys, if you haven't already, do subscribe to Adam Eakin. He's also got a channel. He's also got some interesting content on there. Do definitely go, and he can teach you a few things. Yeah, but I'll give you a shout on Skype sometime. I'm glad you're enjoying my content. I am trying to, how can I put it, be more grown up. So yeah. So yeah, that was quite a weird Discord Wednesday, because usually on Discord Wednesdays I have people actually joining in and talking, but there was nobody joining. So I had to ramble on myself. And that's flats. Oh, that's a tangled web that we weave when we practice to deceive. Okay, don't understand. Scott. Don't understand that guy, but okay. I think you're trying to say you are Scott, and that's flats. What I've realized, actually, I've been getting some really weird troll accounts, really trying to be creative with my name, which is quite cool. So that means I'm really getting under your skin. Yeah, so anything else you guys want to talk about? Because it was actually about the perspective of how you observe reality. That was the actual topic, but instead we had to go talk about sextants and, well, perspective on why we have the observation. Okay, back to the poll. Does your perspective on life make a difference on reality? Yes, 52%, no, 27%, and only for me, yes, 21%. I'm going to say only for me, yes, because I think it's simple. It doesn't matter what my opinion is or somebody else's opinion. It's not going to change reality. If it's a flat earth, it's a flat earth. Doesn't matter if I believe it's a globe or a donut, it stays a flat earth. So that's why I'd say only for me, yes. So I'm going to take that yes as 51% is probably most of the globers. Hey Professor Phil, good to see you. Professor Phil, on your diagram you should be able to see Polaris from South Africa. South Africa falls underneath that line. Sorry to tell you that, Phil. And sometimes with, due to refraction, you can actually see it in, I think it's Malaysia, which is a bit past that. So yes, but not in South Africa. Definitely not be too far down. I'm definitely not 5,400 nautical miles away from the GP of Polaris. I don't know where you come on that. Exactly, Flat Sabbath. It's not easy to help ballers. We do try our best. Derek Nelson, hey, good to see you. Think you could, yes. Sextants require a flat baseline. The geometry proves it. I had people actually talking about it, showing everything validation. Quantum Degree, so good to see you. Thanks for being here. Shh, don't tell the people we have high IQs. They don't like that. No, Adam Eakin, he doesn't understand the presentation. They all don't. That's why they show videos like Gracious Cove presented, showing angles on a horizontal and trying to call it globe. Yeah, how's those NASA scrubs? What happened to everybody making fun of me, telling me, oh, I'm going to cry when Artemis is taking off? Hey, Jeff Gassett, glad you could make it. It's good to see you again. Sorry, you were also one of those that were blocked. Kevlar actually messaged me this morning. If it wasn't for him, I wouldn't have checked my blocked list, and you guys wouldn't have been unblocked. So again, thank you, Kevlar. I really, really do appreciate it. And I haven't actually shouted my Patreons out yet. So thank you, Patreons, for helping me. You guys are really supporting this channel. I do appreciate it. Every little cent helps, because I'm saving up for a new mic, and I'm going to save up for better lighting, and obviously a longer Ethernet cable, and at the moment I'm using my television, so I'm going to have to get a monitor as well. Then I can build my studio in the garage. But for now, I'm quite comfortable on the couch. Let's see, Davey Z. But all plain believers have turned away from the indoctrination of the globe. Yeah, they're actually fighting for flat earth without even believing, without realizing it. Gary Wybinger, elevation angles to the sun or Polaris are just field of view perspective angles. Exactly, that's what I was trying to show with the field of view dome. It's simply the field of view dome moves with you as you move along. Because you have a 360 degree field of view on your 180 degree plane, you can only see based on perspective to that max. So when that reaches the horizon, that's the limit you can see, and that's why when you see a sunset, it's just reached that alignment. It's gone to that limited angle. That's why the sea now has a much larger angle, which compresses and occults that sun. So in other words, it foreshortens the sun, and you don't see you see the sun setting. Adam Eakin, the Earth is flat. Why can't we see Polaris from South Africa? Professor Bell, I explained why. I don't know. Are you kidding me, or does this not make sense to you, Professor? Very simple. Let's show you once again, Professor Phil Bell. Pay attention. I hope you're paying attention. This is a field of view bubble. This is the field of view of Mike standing 90 degrees under Polaris. This field of view bubble is very limited. It can only be to his maximum of 180 degree baseline. If he had to walk away 10 degrees, he would be 600 nautical miles away. See the math? It all works out. Based on 90 degree, it's flat. This is flat math, okay? 600 nautical miles away. Where is the 80 degree sitting now based on his angular measurement from his zenith? Same GP, same plane. See? GP on the same plane, GP on the same plane. This is the celestial sphere. This is his field of view. When he moves away, is that angle not keeping to the celestial sphere? Oh, wow. Now tell me, Professor Phil Bell, is South Africa 5,400 nautical miles away? No. You see, that is 0 degrees at the moment, 5,400 nautical miles away. That means it makes your equator 10,800 nautical miles. I am underneath the equator, so I am past the limit that we can see. Hence why I see the southern stars. I see some northern stars that are in my field of view bubble. Very, very easy to understand. So yeah. Can I explain it any easier? I don't think so. Exactly. Even on the video I showed, it said it's linear distance. Can be translated as linear distance. Why? Because you measure an arc in the sky. Adam Eakin, his presentation is garbage. How high is Polaris? Professor Fulbell, Polaris doesn't have an actual height. Obviously it has an actual, but you can't measure it because it's an apparent altitude. They don't actually drop. Exactly, T Brown. It's an apparent drop. We don't literally see them drop. It's apparently. Don't you guys even... The presentation I just showed with the guy with them explaining with the sextant how it's having an altitude, apparent altitude drop. It's keeping with the arc. It's keeping with your field of view. Oh, wow. Sorry, Professor Fulbell, but for someone that's a professor, you're not really bright, dude. Davey Z, I am always puzzled at why Globus spend so much time and energy coming to our streams with no incentive. I 100% agree. It's the level you have to go to lie to yourself to stay at Glober today is beyond insane. I wouldn't be able to lie to myself like that every day. I can't. Travis, good to see you. Glad you could make it. Earth is flat. Just follow the lies first if you can't understand apparent law. Exactly. It's as simple as that. Not the proof it's globe at any expense. It's just globe. Because globe. Yeah, exactly, Jeff. That's all they say. It's because globe, it has to be globe when they show us flat. So I'm going to show you how it's a globe by first taking measurements of flat. That's practically how the argument is going. Yeah. Cognitus is very real. Definitely. Thank you all again for joining. It's a very late stream. But it's well worth it, I have to say. It was good to be able to get my presentation out there once again. Quantum degree, sir. Andrew Johnson, we don't speak of scale here. That's a bad word for something invented by Globers to explain why the relative perspective physical compression. Yeah, 100% agree. I'm planning on doing a presentation on Blackpool Towers on why it is just perspective dropping, because I tried to explain it before and I think I've come up with a way to make it more coherent. So soon that will be going. Also, I am still going to do the Sextant challenge for McToon. Sorry I haven't got to it yet because I am just really busy with my daughter's ballet and her hockey and everything, and we literally have been working late quite a few nights, so it's difficult to actually do those kind of things because those presentations and everything take much more work than being able to do a stream. So yes, I'm going to get there, guys, and also in future I still want to do the video for Professor Phil Bell with the Cavendish so-called experiment, but I'll get there, guys. Okay, Brenda, the horizon is not horizontal flatsoid. You understand? No, it's called horizontal. Horizon, horizontal plane. Even on the video, the guy says horizontal. Yeah. But Brenda thinks there's 3 horizons. Brenda also thinks shoe is a phenomena, so I wouldn't take anything Brenda says seriously. What did Professor Phil Bell, is that a serious, because what did you say? Can you actually do basic trigonometry? Professor Phil Bell, yes, Adam can do trigonometry. He's actually very good at math. He's a pharmacist, so you would have to know math to do that. Weird. Yeah, and obviously we've been showing trigonometry this whole time to you. But yeah, what does that help? That's why we get people trying to strawman us with calculus that's got absolutely nothing to do with sextants. You think we would be able to do these calculations and presentations and explanations without actually knowing any trigonometry for? Yeah. Because I don't think you guys noticed, since I've actually done this presentation, McToon has been dead quiet by me. Because he knows he has no foot to stand on when I'm actually going to do the presentation by debunking, doing his so-called challenge, because there's not going to be any globe involved. I 100% agree, Adam. We're not here to soothe his cold pain. If he's too dishonest to actually just look at himself and say, listen, yeah, I cannot stop lying to myself, that's his own problem. Yeah. So yeah, there's not really much we can say. Got about 20 minutes still left for chat. What else can I show? Let me see if I can try. He's a chemist supervisor. You have to be a pharmacist to be a chemist supervisor, Brenda. You do know that, don't you? Actually, oh wow. I don't know. I have no words. Hey, Debate Night, good to see you. He already knows I'm going to do the challenge, Debate Night. He's known this for a long time. Because Ruaf also gave me 4 questions I have to do with it as well. So I'm going to be doing those 4 questions as well. Let's see if I can find something more to show you guys. Yeah. I don't know what else we can really talk about with perspective, because I was really hoping somebody would come on here. Sorry guys, I don't know what we can really talk about because, yeah, like I was saying, I was hoping somebody would come on here and talk, but no one has really come on. Okay, so we can just carry on mumbling about Brenda not understanding that a pharmacist, to be a pharmacist supervisor, you need to be a pharmacist. I mean, really. What's taking so long, Debate? I just explained it 5 minutes ago. I'm very busy with doing streams for you guys and personal life. I mean, I got a life outside of YouTube. Like, I got work, I work late. My daughter's been doing a lot of her ballet and her choir and everything, and her hockey things. So we've been very busy. So yeah, I mean, she's made it to the finals for her in South Africa for the choir competition, which is in 2 weeks. Well, in 3 weeks. In 2 weeks it's her birthday party now. So next weekend is her birthday party. The week after that it's the choir one, and she's got now this weekend coming as well another ballet recital. So it's keeping me quite busy, and I'm having family coming over next week. So that's why I said next week I'm only going to have a Wednesday night, and then a Sunday morning I'm moving to Sunday evening. So yeah. Thank you, Davey Z, for your support. I wouldn't have done it without you guys' support. I do appreciate everything, and yeah, I don't really, how can I put it? I've learned to kind of deal with the negativity coming from the Globe guys, because I don't take it personal. It's an emotional thing for them, and I'm here to help them. As simple as that. And you guys are here prepping me and helping me. So without your guys' support, it really does help. Thanks, guys. Because actually your support is immensely very important to me. I do appreciate you guys a lot. Let's see. A real pharmacist would not think the earth is flat. And why is that, Tamay? That kind of sounds like a bigot kind of statement to me. Because there's so much people today that have PhDs and things that say it's not the spinning testicle in space. So I don't think you really have anything. Yes, Brenda, I also dislike liars. That's why I like to mute you. Because you are proven liar. You can be glad I'm letting you at least comment on here. Because liars like you, frankly, yeah. But I've got a soft heart, so I forgive you and then I move on. But then sometimes you push me to an edge where I just don't want anything to do with you anymore. Yeah, exactly, Fat Sabbath. So she dislikes herself. I mean, yeah. Attack Adam, but not know the difference between superintendent or supervisor pharmacist. Yeah, superintendent. That's even worse for Brenda. Adam, don't you think usually if you become a superintendent or even a supervisor or whatever, you have to actually know what's going on with the job? I mean, when I was the foreman for at BMW, I actually had to know what was going on with the whole scene because I was the foreman. Yeah, I'm not going to become a foreman if I don't actually know what's going on. It's the same thing. So yeah. What's Brenda saying? I would be willing to go 1-to-1. I would give you the opportunity to prove I am a liar. I already proved you're a liar. I got streams on you showing you contradicting yourself and lying. It's as simple as that, Brenda. If you don't believe me, just go look at my streams. Professor Fulbell, flat earth perspective. If the angle of elevation of a triangle is 45 degrees and the adjacent side is 2,701, how high is it? Listen, it's an apparent altitude angle. Just because you want to give an actual height to it, Professor Bell, is your problem. And like I said, because you guys use triangles and you guys, did you hear that guy? He said actual height. Oof, he's giving an altitude height when using an sextant. So he's giving a physical height. So when you were saying that you're giving an actual height to the sun of 2,700 nautical miles, not us, we're saying it's an apparent altitude because it's an optical measurement. So when you're saying the sun is at a physical location and you're using a sextant and you're claiming a globe, you are saying the sun is 2,700 nautical miles away from the earth. Yeah. Hey, Will Gascon, good to see you. Glad you could make it. Thank you for coming in. Debate night. Flat perspective. No, it's a measured height. You're not understanding. This is your measure. It's a measured apparent altitude. Do you know what apparent altitude means? It means it's an angular measurement. An angular measurement based on your perspective. It's not physically where you are measuring it. It's apparently there where you are measuring it. Hence why its apparent altitude changes when you take different angular measurements. Yeah. Well, Gaston, we do have asked Phil Bell a lot for his dissertation. He just ignores it straight, so... No, triangles do not have apparent sides. Actually, a triangle is an apparent because it's geometry. It's not physical lines drawn, Phil. So when you do your trigonometry of a triangle, it's an apparent line. It's a drawn-on line. It's not physical. You don't literally see a line in 3D space, do you? No. You are absolutely clueless, Debate Night. Sorry, is Debate Night not Sean Hawkins? Because he's talking a lot like how Sean Hawkins is the, you know, because Sean Hawkins is quite an idiot. Phil is a pro now, yeah. Blargo, in your flat model you have measured an angle, a right angle and a flat baseline. Solve the triangle. We already have solved it. That's how we get the distances and that's how we get everything to show how it's working. Don't know if you missed it, Blogger, but you might want to go back to the beginning of the stream when this is over, where I show with presentation and people explaining it to you, even based on your globe. You require flat, and you have to throw, you don't require your globe to have the measurement. No, Sean, I do not have you blocked, so you can actually try use your Sean Hawkins account if you really wanted to. I do not have you blocked. I did block you before because I got sick of your idiocy, and yeah, but I did unblock you again because I have a soft heart for you, Sean. I understand that you're not very bright, and well, it takes time to get that into your head. I hope you paid attention tonight why your Polaris challenge wasn't a challenge, because it's, yeah. Well, Gassini is a pro liar, exactly. Okay, quantum degree, sir. I've been saying that too. Physical triangles do not exist. Exactly. The only physical triangle you can get is, let's say you make a plastic triangle or something, then it's physical because you've made an object. But when you do triangles and triangulation, it's not a physical triangle. I don't know why they would say it's physical. Pirate Man, when I look at you, am I seeing you or the apparent you? You're seeing the apparent me because you're seeing me on a screen. You're only seeing me if you are sitting right in front of me, Pirate Man. And then it also comes to, do you accept FTFE's refracted hand argument? Note, guys, he still hasn't demonstrated it. After sending him an email, see, he's already demonstrated it. So, and that was how long ago? Yeah. So, shout out to FTFE. When are you going to show your refracted hand demonstration? So no, you're not really seeing, you're seeing apparent me because you're seeing an aberration of me on your screen. It's not physically me seeing on the screen. Am I actually that size on the screen? No, I'm not. Does that make your point? Does that make it a bit easier to understand? Okay. It's 10 to 12 already. Can you believe it? I tried to comment on my Sean Hawkins account, still blocked. Really? I don't think that's true. Let's quickly check. Because I did go and unblock you today as far as I know. I can go, let's see. Settings. Where do I go on the computer? Advanced settings. No. Oh, I got billings and payments now already on. That's quite cool. I can enable that. Ha. I'm getting used to this whole monetization thing. So there's quite a few things I have to get onto it. Cool. Okay, so I've got that on now. Settings. Let's see if I can change. I usually do it on my cell phone, so I don't know. Where do I get the community on here? Maybe I have to go to my channel? Sorry, I'm just trying to look, Sean. YouTube Studio. I think I have to go to YouTube Studio first. There we go, then settings. And community, okay. Let's see, Sean Hawkins. No, I do not see Sean Hawkins blocked. Oh, there we go. Sorry, you were blocked again. Okay, sorry about that. I thought I saw you out. But you are now unblocked, Sean Hawkins. You are welcome. Please just do behave yourself now. No worries, Will. It's fine. They do frustrate a person so much that you don't really worry about spelling and grammar. I'm 100% with that. Because usually they attack the person's grammar and spelling and the character instead of the argument. That's how it works with these guys. Hey, I see the yeses dropped down to 48%. And no 32%, exactly. Because your opinion on it does not change reality. I hope the guys are actually starting to understand why I put this poll up. Yeah, and I am also working on the presentation for What's It Gets It and stuff with the ether. It's probably gonna challenge a lot of people on what they believe, let's put it that way. It's gonna challenge a person to see if they're honest with themselves, kind of thing. So it's gonna be quite interesting. Okay, Sean, so did you get the actual argument of what I presented tonight? Pardon, man, you seeing a flat image of me? Yes, it's flat because it's a two-dimensional plane. But okay. But this two-dimensional plane, which you are looking off of, has depth though, so it's actually three-dimensional. Okay, well, you're probably going to do a stream about it later on, because I see you're doing streams about everything I say about these days. But yeah, please do go and watch the stream, and it would be highly appreciated if you can see if you understand what I was trying to say. Thanks, Sean. Do appreciate it. Okay, guys. I think it's 12 o'clock. It's getting a bit late now. I have to get up in about 4.5 hours. And I might work late again tomorrow night, so I think I have to get some sleep in. So thank you everybody for coming. Do appreciate everybody here, even you Globers. I appreciate all your support. Would be great if anybody feels the heart to be able to just hit the like button and just share. And if you're able to just support me financially somehow by becoming a Patreon, it's only $3 a month, or I do have a Bitcoin link below as well. So thank you everybody, because I am trying to save up for better equipment so I can have better streams and everything for you guys. So you guys rock. Peace out. God bless. So see you guys Wednesday evening. Not this late though. Cheers guys. God bless.